Hello guys, welcome to the DMS Online School. If you are new to this channel, you are most welcome. On this channel, I teach mathematics, biology, science, and also revise past examination papers. Today's lesson is a mathematics lesson that will be looking at the equations. Alright, as usual, I don't waste much of your time, so I just go straight into the lesson. Let's look at what an equation is. So an equation is a mathematical statement that two algebraic expressions are equal. In other words, an equation is an algebraic expression with an equal sign. E.g., if you have x plus 2 equals 0, such an expression here is an equation because it consists of a variable and an operation and a number and then an equal sign in between. Alright, so also if we have y plus 6 equals 2, this 2 is an equation because it contains as well a variable y and also an operation plus and a number 6, then an equal sign and also a number. Equally, this is also an equation where we have y plus 6 equals 8. Alright, so this 2 is an equation because it consists of a variable y and an operation plus and a number 6 and then an equal sign and another number. So when we say an equation is a mathematical statement that two expressions are equal, this is what we mean. And also here we said, in other words, an equation is an algebraic expression with an equal sign. Remember in my introduction to algebra, if you want to click that video, you can watch the link which is appearing here, where we looked at algebraic expression as consisting of variables and also operation like plus. But the moment we introduce an equal sign in an algebraic expression, then it becomes an equation. Alright, so in short, we are saying an equation tells us that the terms on the left side of the equal sign are equal to the terms on the right side of the equal sign. So for instance, in this situation here, the terms on the left side here, they're also equal to what is on the right side here. So here on the right side we have 0, which means that the terms on the left side, if they're added, they can give us 0. Equally, in this equation here we have 2 on the right side of the equal sign and the y plus 6 on the left side. So this simply means that if we add y plus 6, this will give us 2. Equally, on this algebraic expression here we have y plus 6 equals 8. So on the right side we have 8, which means that also on the left side of the equal sign, if we add y plus 6, we can get 8, meaning that the numbers that are being held by these variables here. Alright, so let's continue. These equations you are seeing here are nothing but what you have looked at way back in your learning in years, like in grade 1, because these expressions in grade 1 were represented or expressed as a black box plus 2 equals 0. So you see, instead of having x here, they used to represent an unknown number with a box here. But as we grew up later in grades, then they introduced the x here, and then they were asking us to solve for x. So these are the things which we used to do long way back when we were still in grade 1, grade 2, if you can remember very well. But as for me, I can remember very well. So in this equation here, what it means is that if we have 0 on the right side here, that simply means even on the left side here we have 0. That means that if we have positive 2, what is it that we can do to positive 2 in order to get 0? That means that we have to subtract 2 from 2 in order to get 0. So here we'll have minus 2 plus 2 in order to get 0. Alright, so this means that this x here, which is represented by the box here, is equal to negative 2. Equally, here we have y plus 6 equals 2, so can be expressed as blank box plus 6 equals 2. So in this equation also you can find out by saying what is it that can be done to 6 here in order to remain with 2? So you can know that in order to remain with 2 in 6 here, you have to subtract 4 from 6, which means here you have minus 4 here, then plus 6 equals 2. So which means y here is represented by -4, or holds a number -4. Equal here we can say a blank box plus 6 equals 8. So we can try to find out a number that, or we can just ask ourselves, what is it that has been done to 6 in order to get 8? So a 2 has been added to 6. So this box holds 2 plus 6 equals 8. All right. So y here holds the number 2. So in computer science, such variables like x, y here, they are called memory storages, or they actually represent numbers that are not yet known or represented to you physically. All right. So in mathematics, we call these variables, and whenever we are dealing with equations, it means we have to find the number represented by the variable. All right, so what we should know here is that equations deal with solving for the unknown variables. So whenever you have equations like this, it means that in that particular topic, you'll be dealing with solving for unknown variables like these. E.g., we are saying the unknown variables in the above equations are x and y. All right, so we solve these equations by collecting or grouping like terms together to remain only with the unknown variable on the left side of the equation. So as you can see, these are equations here. So in order to solve these equations, like I have done previously, we have to collect like terms such that we remain with only a variable on the left side of the equal sign. All right, so for instance here, if we were to solve this one now the way we solve in mathematics, we have to collect like terms together to ensure that on the left side of the equal sign we remain with only the unknown variable. So in this expression of ours here, we have the variable x and 2 and then 0. So x and 2 are not like, they're not like terms. X is a letter, 2 is a number, but here also we have 0, which is a number. So 2 and 0 are like terms. So by solving equations, we have to collect like terms together. So which means that these two can be collected to the other side to make sure that we remain with the unknown variable on the left side of the equation. So this side we just have to remain with x. So these two then crosses. So whenever 2 crosses, it becomes a negative. So here we remain with x, then we say equals, then 0, then 2. When it crosses, it becomes negative. All right, so from here you say x is equal to 0 minus 2 is minus 2. In short, in 0, can we get something out of it? No, so we'll still have minus 2. All right, so equally here, if we are to solve this one, you have to collect like terms together. So in this equation, 2 and 6 are like terms, while y is a variable, so it has to remain on its own on the left side of the equal sign. So this has to cross, so we remain with y equals 2. So the moment 6 crosses becomes negative 6, then we say y is equal to 2 minus 6, which will give us negative 4. All right, so check the answers here are the same with what I showed you previously. So here also we can say y plus 6 is equal to 8. So 6 and 8 are numbers, so they must be collected together on the right side of the equal sign, so that we remain with the unknown variable on the left side of the equal sign. So this 6 will cross, so remain with the y is equal to 8. Then when 6 crosses becomes minus. So we'll say y is equal to 8 minus 6, which will be 2. Alright, so we are saying such equations are called linear equations in one variable because they only contain one unknown variable. So we have one unknown variable here x, y, y. So such equations like these ones here, they're called linear equations. All right, so let's look at more examples of these linear equations here. All right, so we have this equation here. It is a linear equation because it only have one variable x, and also here we have a linear equation because we only have one variable x. Equally, this one is a linear equation because we have one variable x. Equally, this one is a linear equation because we have one variable x, as well as this one, it's a linear equation because we have one variable x. Then the last one, this one as well, is a linear equation because we have a variable y. So these variables here, they are raised to power 1. So a linear equation, they are called equations of 1 degree or degree of 1, meaning the variable which is there is raised to power 1. All right, so let's see how we can solve these equations. All right, so let's begin with A. So as usual, when we look at 2x minus 1 equals x plus 3. So for us to be able to solve these, we have to ensure that we remain with a single variable on the left side of the equal sign, so that we have all the other variables which are numbers. We have all the numbers on the right side of the equal sign. So how are we going to do that? By collecting like terms together. So 1 is a number, so it will cross to the right side, and 3 x is a letter, and then it will cross to the left side of the equal sign. So here we have 2x, then this x, when it crosses, it becomes minus x, then we drop an equal sign here, then we'll have 3. So when this minus 1 crosses, it changes from minus to positive 1. Then from here, these are like terms, so we can easily subtract 2x minus x, which will give us x. Then equal sign will drop, then we add 3 plus 1, which will give us 4. So we have solved this this equation. So let's go to another example here, B. So B says 7 open brackets x plus 3 close brackets minus 2 open brackets x minus 4 close brackets is equal to 4. So how can we solve this equation? So in order to solve this equation, first we have to multiply or to clear out the brackets by multiplying the numbers in front of the brackets with everything inside the brackets. Like here, we have to do 7 times x, which will be 7x, then the same 7 times 3, which will be positive 21. All right, so then also here we have to do negative 2 times x, which will be negative 2x. Then we have also to do negative 2 times negative 4, which will give us positive 8. Then we'll say equals 4. So we have cleared out the brackets here. Then from here we have to collect the like terms. So we have 21 as a number and 8 and then 4. So we have also 7x and also 2x. So these are common, so they will remain on the left side of the equal sign because they contain the variable x, but these they'll cross on the right side of the equation so that we remain with the terms that have got the variables only. So what we are going to do, this will cross and also this will cross. So here we'll remain with 7x, then minus 2x, then equals 4. Then this one, when it crosses here, it becomes negative 21. Then this 8 also becomes negative 8. Then from here we are going to same 7x minus 2x will remain with 5x equals, then here 4 minus 21 minus 8 will give us negative 25. So for us to be able to remain with the x here, since between x and between 5 and x there is a multiplication, so for us to get rid of this 5 we need to divide. The opposite of multiplication is divide, so we have to divide by 5. Also, whatever we do on the left side of the equal sign also must be done on the right side of the equal sign so that the equality is not offset. So say divided by 5. So 5 into 5, it will cancel, will remain with x equals, then 5 into negative 25, it will give us negative 5. So here x is equal to negative 5. All right, so let's move to another question here, which is a C. C says 3 over 2x minus 1 over x is equal to 1 over 4. So you notice that this side we have quite these two terms that are fractions. So for us to solve this one, we have first to put these fractions as a single fraction. So how do we do this? By finding a common denominator in which these denominators can go without giving a remainder. So in this case, the common denominator is 2x. So we'll say over 2x. So the common denominator is 2x. So what we are going to do here, we'll say 2x into 2x. How many times can it go there? 1. Then 1 times 3, it will give us 3. Then the minus will drop here. Then we'll say x into 2x. How many times can it go there? 2. Then 2 times 1, which will be 2, equals 1 over 4. Then from here, 3 and 2 are like terms, so we can quickly evaluate this by saying 3 minus 2, which will give us 1, then over the same 2x equals 1 over 4. Then for us to get rid of these fractions, or here we have to get rid of these two fractions because we have already made this one as a single fraction. So now we have to get rid of the fractions by cross multiplication. So we'll cross multiply where 1 will multiply with 4, and then 2x will multiply with 1, and when multiplying we'll start with the variable or with the term containing the variable. So 2x times 1, it will give us 2x, then equal sign will drop, then 1 times 4, it will give us 4. Then what we are going to do here is to divide. To remain with x, we have to divide by 2, and also here by 2. So 2 into 2 will remain with x equals 2 into 4, 4. All right, so let's move to another example. So this is example D. X minus 5 over 2 minus 3x plus 1 over 5 is equal to minus 3. So again, as you can see, this one is a fraction, so we need also to express it as a single fraction by looking for a common denominator in which 2 and 5 can go without a remainder. In this case, it is 10, so we'll say 10 here, then we'll say 2 into 10. How many times can it go there? 5. Then 5 times this expression above the 2. So same 5 times this expression. So this expression will be put in brackets because 5 is multiplying with that expression. Then minus will drop here. Then we'll also say 5 into 10. How many times can it go there? 2. So 2 times this expression above 5. So we'll get 2 put here, then this expression will be put in brackets, meaning this 2 is multiplying with what is inside the brackets. So equal sign will come here, -3. Then remember, these brackets have to be cleared out by multiplying 5 with everything in the brackets and also 2 with everything in the brackets. So we'll say 5 times x, which will be 5. Okay, so we'll say over 10. So we'll say 5 times x, 5x, then 5 times -5, it will be -25. Then we'll say minus 2 times 3x, it will be minus 6x. Then minus 2 times +1, it will be minus 2. Then equals -3. Then here we are going to collect like terms. So 5x and 6x are like terms. Then 25 and 2, they are like terms. So we'll say over 10, then we'll say 5x minus 6x, then minus 25, then minus 2 is equal to -3. Then this one will say 5x minus 6, it will give us minus 6. Then we'll say -25 minus 2, it will give us minus 27. Then here we'll say equals 3. So here what we are going to do, since we have no space, we'll move a bit up. Then after moving a bit up, for us to clear out this fraction on this side, we have also to introduce a fraction on the other side by just saying -3/1 here. So 1 does not alter anything, because if we say 2 divided by 1, what is the answer? 2. So 2 is still 2. So even in this -3 is still -3 even when we divide it by 1. But putting a 1 below here makes it a fraction, which enables us to do our work. So we'll cross multiply here to clear out the fraction. So this term which contains the x, this one -x minus 27 times 1, which will give us the same x minus 27, because anything times 1, it's that thing. So equals here, then we'll say 10 times -3, which will be -30. All right, so we have run out of the space, so we'll shift here. So we are going to say this now will cross, because -27 and -30 are like terms. So for us to remain with x, this must shift. So we'll say -x is equal to, then -30, then this, when it crosses, it becomes +27. Then we'll say -x is equal to -30 plus 27, which will give us -3. Then for us to get rid of this negative here, we multiply everything with a -1. So -1 times -x, it will give us x equals, then -1 times -3, it will give us 3. So this will be the answer. All right, so guys, we have come to the end of this video, but I still have homework for you to practice. I have these 2 questions here that I have left for you to practice. All right, so notice in this one, so this is single, this is single. You can simply just cross multiply to get rid of the fraction, and then do as I've done in other questions here. All right, this one is straightforward. Just collect like terms, as simple as that. So guys, I hope you enjoyed this lesson, and if you learned something from this lesson, please guys, give me a like and let me know in the comment section. Thank you for watching the DMS Online School. See you in my next video. As for now, bye, and please, peace.